Good mornings. Today we are going to learn about volume. We are going to learn about volume of cubes, number 2, cuboids, triangular prisms, and the cylinders. A very important topic and very common in the exams. We are going to start with the volume of cuboids. A cuboid is just like a box. A cuboid is just like a box like this. Yes, this one is an example of a cuboid. We are going to start with cuboids and be very much keen. This is a very common question in the exams. 10, let the length be 10 centimeters, width 8 centimeters, and the height 4 centimeters. Class, volume of cuboids is just the formula is only one. Length times width times height. I repeat again. Volume of a cuboid is length multiplied by width multiplied by height. In our case here now, the length is 10 centimeters, the width is 8 centimeters, and the height is 4 centimeters. Class, 10 times 8 is 80 centimeters. Then you multiply by 4. So our 320 centimeters cubed. That's how we get volume of cuboids. Very common question in the exam. Another very good example on volume of cuboids. I give you another cuboid here now. Let the length be 6 centimeters. Let the width be 5 centimeters. And then let the height be 2 centimeters. Again, we have said the volume of cuboids is length multiplied by width multiplied by height. So in our case here now, we have 6 centimeters. You multiply it by 5 centimeters, then multiply it by 2 centimeters. Plus 6 multiplied by 5 is 30. Then 30 multiplied by 2, our answer becomes 60 cubic centimeters. I believe I'm very much through with the cuboids. Length times width times height. Now let us go now to volume of cubes. Let me go now to volume of cubes. A cube is different from a cuboid on only one side. A cube, all the sides are equal, unlike a cuboid where the length and the width and the height are quite different. For example, now, once you are given a cube is just like a square. Just a square where all the sides are equal. Look at my diagram. This one is a very good example, a very good sketch of a cuboid. So, in a cuboid, if it's in an exam, you're only given one side. You are the one not to use your mind and your brain to know that once you are given one side, it implies to all the sides. Volume of a cube, again, when you are given here 6 meters, the other side now, automatically, they are all 6 meters. And the volume of a cube is side times side times side. We can also say side 3 times. Like now in our case here, one side is 6. So volume of a cube now is just side 6 centimeters multiplied by 6 centimeters multiplied by 6 centimeters. In our case here now, 6 multiplied by 6 is 36 centimeters squared. Multiplied by another 6 now, it becomes 216 cubic centimeters. That's a very good example of a cube. Another example of a cube so that you understand quite well, I give you still another cube where one side is now 4 centimeters. Let one side now be 4 centimeters. This one is a cube, all the sides are equal. So let one side be 4 centimeters. In class, when you are given one side, now use your mind and the brain to know that a cube, all the sides are equal. So in our case now here we have 4 centimeters multiplied by 4 centimeters multiplied by 4 centimeters. Class now, 4 multiplied by 4, you get 16. 16 multiplied by 4, our answer now becomes 64 cubic centimeters. That's volume of a cube and a cuboid. Very fast, I want to go to a very important and a very common figure in the exams called triangular prisms. This is one of the cases I emphasize every day about triangular prism, where they test almost in all the exams. Even in our normal, apart from KCP, even in our normal exams, they test triangular prisms. And this is how triangular prism looks like. This is a very good example of triangular prism. Very common in the exams. Very common in the exams. This is called triangular prism. A very common figure in the exam. And before we start, this question, they always ask almost all the topics. They will ask you even surface area. They can ask you also volume. They ask you also perimeter. Yes, so this one is a very important diagram that you must not enter an examining class without understanding more about triangular prism. A very good example, I want to give you a very good example here. Here we name this one 3 centimeters. This part 4 centimeters, and let this one now be 10 centimeters. Now, volume of a triangular prism, we normally say now, is now area of the cross-section. In short, cross-sectional area times the length. In our case here now, and I want you to master this, area of the cross-section, in our case here, is area of the triangle. And the class we have done so many times, area of a triangle. Area of a triangle is a half multiplied by base multiplied by height. So in short, just get the area of the triangle, then you multiply it times the length. Area of the triangle, we normally say is a half multiplied by base multiplied by height. In our case here now, our base is 3 centimeters and our height is 4 centimeters. So class, to get the area of the cross section now, you say now a half multiplied by the base, which is 3 centimeters, the height is 4 centimeters. Then now, you multiply now by the length, which is 10. Then you get the volume. Again, get the area of cross-section multiplied by the length. In our case now, you can simplify. If you simplify, it's only a divisible that you simplify before you multiply. So when you say by 2, 1, here by 2 is 2. Then you say 3 multiplied by 2, and again multiplied by 10. 3 multiplied by 2 is 6. You multiply by 10, you get 60 cubic centimeters. That's how we get the volume of a triangular prism. In some cases, they can give you even the area of the cross-section. In one of the exams that we did recently, they gave you the figure of a triangular prism, and again, they gave you already the base area. Already they gave the base area as 50 centimeters squared. Already the base area is given, and here you are given 10 centimeters. Then they ask you, what is the area? Class, once you are given the base, the area of the cross-section, you don't need to look for the area of the cross-section again. Already you have been given. So why do you bother yourself? In our case here now, in our previous exam, they gave you the base area or area of the cross-section as 50 centimeters squared. So your case here now is only to master the formula. Volume of triangular prism is just area of the cross-section multiplied by the length. In our case here now, the area of the cross-section is 50 centimeters squared. And the length is 10 centimeters. In our case now, our volume now is area of the cross-section times the length, which is 50 multiplied by 10. You get 500 cubic centimeters. Class, I believe we are together there. That's how we get volume of a triangular prism. That's how you get volume of a triangular prism. But I am warning you again, because now you are preparing for your exams. Don't just wait to be given everything straightforward like that. Last year, they gave a very good example of a triangular prism. Let me just rub mine. They gave a triangular prism just like this one, mine. I know you to draw another one. This one is enough. Then, here, they say here is 26 centimeters. They gave you another side, which is 25 and 10. So here they said here is 25 centimeters, and here they said it's 10 centimeters. Then they are asking, find the volume of that figure. Find the volume of that figure. You are a candidate class. So you must be very much keen and very observant when you are working out. When you look at that figure now, the examiner is having a trick somewhere. Now, remember, I've said you get area of the triangle and the length. When you look at the triangle now, this side now, if your mind is fixed on triangle, you find that you're only given the base and you are not given the height. That one becomes a problem to many of our candidates, not even in our school, but even countrywide. So, and before I'd warned all the students that be very careful with the formula that you are using. The formulas are okay, but the examiner will twist the problem so that you don't get the answer. Now, in our case here now, already I've said volume of a triangular prism is area of the cross-section. In our case here now, is area of the triangle times the length. And the examiner knows quite well that you know that area of a triangle is a half multiplied by base multiplied by 8. In our case here now, the base is given. When you look at, when your eyes are fixed on one triangle, you are given the base, the height is not there, the hypotenuse is not there. So class, I want you to open your inner eyes and you see the hypotenuse is given on the other side of the triangle. In our case here now, the hypotenuse is given at 26. So let our the length of hypotenuse here be 26 centimeters. So in class, when you come now to area of a triangle, half multiplied by base multiplied by height. In our case now, we don't have the height. Class, I told you earlier, before you look for the area of that triangle, you have to look for the base because the height, because the height is not given. Once you are given the hypotenuse and you are given the base, you just square the hypotenuse, subtract by the square of the base, and then you find the square root. In our case here now, to get the height, now you say 26 squared, which is 676. Then we have 10 squared, which is 100. Then you take away. When you take away, you get 576. And the square root of 576 class is 24. So our height here is 24 centimeters. Now, from there now, you can now get the area of the triangle, which is a half multiplied by base multiplied by height, which is now a half. Our base becomes 10, and our height is 24. Then times the length, which is 25. Then now you'll be able to get the volume. This is what they tested last year. And I'm afraid they will test again this year again. So by 2, 1 by 2, we have 5. 24 multiplied by 5, you get 120. Then you say 120, you multiply by 25, then you get the volume. 5 multiplied by 0, you get 0. 5 multiplied by 2, you get 10, which is 0 again, carry 1. 5 multiplied by 1 is 5 plus 1, you get 6. 2 times 0 is 0. 2 times 2, 4. 2 times 1, 2. Then when you add, you get 3,000 cubic centimeters. That's how we get volume of triangular prism. Very fast, I want us to go now to volume of cylinders. Again, a very common question in the exams. Volume of cylinders. Volume of cylinders. We have open cylinders, we have closed cylinders, and we also have cylindrical cylinders. Let me start with volume of open cylinders. A cylinder is like this, and sometimes you are told it's open, sometimes you are not told it's open. You are the one now to use your mind and your brain to identify which one is open and which one is closed. For example, in major exams and in this KCP, advanced KCP exams, they don't talk of a rod, a metal rod. A cylinder in the form of a metal rod. Once you hear a metal rod, that's a metal, that figure already is closed. Don't argue again. You get a metal rod, that rod is closed. So now we are going to start surface volume of cylinders. Volume of cylinders, whether open, whether closed, volume doesn't matter. So we are going to start with volume of cylinders. So here now, for example, here the radius is given 7 and the height is given 10. So I don't want a case where many of you they say open. When we are talking volume, it doesn't matter whether it's open or closed, the volume remains the same. So volume now is the volume of a cylinder is just 5 r squared h. 5 r squared means area of the cross section. And I want to repeat it again. In short, all figures, when you calculate volume, what's important for you to understand is the cross-sectional area. Even when I tell you the volume of a cylinder is 5 r squared h, 5 r squared now is area of the cross-section, area of a circle, which is 5 r squared multiplied by the length. So in short, all the figures, you can only use one formula. It should also be in your mind. Cross-sectional area times the length. In our case now, here, our cross-sectional area is pi r squared, area of the circle times height. Phi we used as 22/7. Then already the radius you are given as 7 centimeters. So times 7 centimeters, then times 10, then you are going to get the volume of the cylinder. Simplify, if it can be simplified, by 7/1 by 7/1. So we are left with 22 multiplied by 7 multiplied by 10. 22 multiplied by 7 is 154. These things you should master them in your brain, not every time calculating. Remember, in an exam, you only give it 2 hours to do your work. So I don't want to see students wasting a lot of time doing simple multiplication. You make your mind busy, and your mind will work it out. So 22 times 7 is 154. Then you multiply it by 10. The answer becomes 1,540 cubic centimeters. That's how you get the volume of a cylinder. Another very good example of a volume of a cylinder, you can be given now another cylinder, where now the radius, now you are given the diameter. You are the one now to know, to determine the radius. Like now here now, you are given the cylinder like this. You are given the diameter as 7 centimeters and the height as 20 centimeters. Class, volume is base area, area of the cross section. That means pi r squared multiplied by the height. Which phi do you, unless you are told, always use phi as 22/7. So here we have 22/7. Now, if the diameter is 7 class, to get the radius, you don't need to divide. Just say the diameter over 2. Whether it's what? The diameter divided by 2, you get it. You don't need to divide. Just say 7/2, which is the radius, multiplied by 7/2, then you multiply times the length, which is 20. Then you simplify where it can be simplified, then you get the answer. Class, by 7/1, by 7 goes 1, by 2 goes 1, by 2 goes 11 times, by 2 goes 1, by 2 goes here 10 times. Now we have 11 multiplied by 7 multiplied by 10. 11 multiplied by 7 is 77. Then you multiply by 10, you get now 770 cubic centimeters. That's another good example of volume of cylinders. Very fast, I want us now we go to volume of a cylindrical solid. This one is a cylinder, but now in the exam they have attendance now of now splitting the cylinder into two equal parts. When it's split to equal parts now, everything changes now. This is a cylinder, but now it's split into 2 equal parts. One side now, we call it a cylindrical cylinder. Now it's not full, it is a half. And very quickly look at my diagram here. Look at my diagram here now. This one is a cylindrical cylinder. A big one for you to see. This one already, it was a cylinder, it has been cut into 2. That's a cylindrical cylinder. Very common question in the exams. Now, let the diameter be 7 centimeters. Let the height be 10 centimeters. Class, I want to repeat again. I'm not going to get tired of repeating. Volume is cross-sectional area. Master that. Cross-sectional area here now means area of the semicircle multiplied by the length. Area of a circle is pi r squared. Area of a semicircle, no, because it's a semi means half, divided into 2 equal parts. Instead of saying pi r squared now, this one will be now a half. Understand this? A half pi r squared. Then you multiply times height. That's how we get the volume of a half a cylindrical solid. Area of the cross-section. At the back, listen carefully. Area of the cross-section. Cross-sectional area. In our case, area of a semicircle. Then you multiply by the length. Area of a semicircle now is a half pi r squared, which is a half. Let the phi be 22/7. Class, I've just said, once examiner gives you the diameter, to get the area, just say the diameter over 2. In our case here now, the diameter is 7. So in our case now, it's 7/2, then multiply by 7/2, then multiply by the length, which in our case is 10. This is area of the base area of cross-sectional area, then times 10. Then where possible, you simplify. By 2, 1, by 2 here becomes 11. By 7, 1 becomes 1. Then now, by 2, 1, by 2 here becomes 5. Now 2 cannot simplify 11, cannot simplify 7, cannot simplify 5. What do? You multiply the numerators and you divide by the denominator. In our case here now, we have 11 multiplied by 7. 11 multiplied by 7, which is 77. Then we have 77, you multiply it by 5. Now we have 77, you multiply by 5. Class, 5 times 7 is 35. So you write 5, you carry 3. So 5 times 7, 35, you add 3, you get 385. Then we have over 2 now. Now we have 385 divided by 2. 3 divided by 2 goes only 1 times. You get 2. Take you get 1. You drop 18. Then it's 9 times 2 because of 18. Then you drop again 5. 5 divided by 2 is 2. 2 times 2 is 4. You minus, you get 1. You add 0. Then you put a point. 10 divided by 2 is 5. So our answer is 192.5 cubic centimeters. Another way in exam, if you don't meet 192.5, I have said many times, 0.5 is the same as half. So look at the choice where we have 192 and a half cubic centimeters. All those things, all of them mean the same. All of them, they are the same. They are the same. In the year 1989, I'm teaching and I show you how the questions are tested in the national examination. Because for sure you are preparing yourself for the national exam. In the year 1989, they gave half a cylindrical solid and they were asking what the volume of the container in cubic meters. Remember volume either in cubic centimeters or cubic meters. Very good example, very fast. I'm going to draw that question there, which was tested back in 1989, and I know some of you, they were not born. Some of you, they were not born by the year 1989. So this question has been tested since the start of KCP. This one is a half a cylindrical solid. The diameter they are giving 1.4 meters and the height 3 meters. Then they're asking, find the volume of the container in cubic meters. You are very lucky that I'm teaching you as it relates to how the questions are tested in the national examinations. Just to repeat what I've said in the other side, volume of a half cylindrical cylinder, you get area of the cross-section. In our case here now, get the area of the semicircle, then you multiply times 10. And the class I want to, once you get a number in decimal form, don't use decimals in the class. Like in our case now, if diameter is 1.4 now, that means the radius is 0.7. Remember I said diameter divided by 2, you get the radius. So our radius here now, our radius now is 1.4 divided by 2, which is 0.7. Class 0.7 in fraction form is the same as 7/10. So I prefer that you use fractions. When you use fraction, the possibility of making mistakes is very minimal. So now, area of a semicircle now, which we said is half r squared times 8. Now we have a half. 5 is 22/7. Radius now we are using 7/10 instead of using 0.7 to avoid confusion of the students. Times again 7/10, then times the length, which is now 3 meters. This is now the base area of area of the cross section multiplied by the length. When you split by 2, 1, by 2 here we get 11. By 7, 1, we get 1. Then we have now 11 times 7 divided by 100. This 100, once you see zeros in the denominators, don't divide them. You'll put decimal place later on. So we have 11 times 7, which is 77. Then we have 77 multiplied by 3, which is 231. Then you divide by 100. These are 2 decimal places. So you just cancel the zeros. You count 2 steps backwards. When we are divided, we go backwards. You say 1, 3, then you 1, 2, then you put point. So our volume is now 2.31 now cubic meters. I believe there now you have understood. Be very careful on this topic because it's a very common question in the exams. The syllabus is reminding us that we should teach up to cylindrical, volume of cylindrical, half cylindrical cylinders. But in the exam now, we see them now combining shapes and they ask you what the volume of the remaining shapes. For example, now, in the year 1994, this was the question. The diagram below shows an open rectangular box. The thickness is 2 centimeters. Then what is the volume of the timber used? This one is a box. There is a hole. It is open. Now they ask you, what the volume of the timber that is now used to make the box? Past KCP question on volume. Vast KCP. This one is an open box. That's why you open your eyes, you broaden your mind. Open box like this. Then you are told there is a hole. Yeah? It is open. I repeat, it is open at the top. It is open at the top. It is open. The box is open. Once it's open, you are told there is a thickness. The thickness between the hole is 2 centimeters all the way around. All the way around, you are told is 2. This is the thickness. The thickness now of the hole, 2 centimeters. Now, what the volume of the timber used? You are given the length is 30, 25, 15. This is 30 centimeters. This is 25 centimeters. This is 15 centimeters. What the volume of the timber that's left that is used to make that container? Now, very simple. Get the volume of the big box, then you subtract by the volume of the hole. Volume of the big box, that is where we started. That's the length multiplied by width multiplied by height. The length in our case here is 30 centimeters multiplied by 25 centimeters multiplied by 15 centimeters. Here now you are going to get the volume of the big box. Subtracted by, you subtract now volume of the hole. And I want to note very clearly how to get the measurements. We are told the margin is 2. So if the length is 30, you have to minus these 2 and the other 2, so that you get now the length of the hole now. That means 2 minus 2 minus 2 the other side. 30 minus 2, 28, minus 2 the other side. So here we are left with 26 centimeters. Whatever you do to the length, you also do the width. 25 minus 2 and again minus 2 the other side, you are left with 21. The width here is now 21 centimeters. And I want you to be very keen on the height. The height, we are only going to subtract only 2 from the normal height. Why? Because this hole is not through. It's not through. This box is not through. When you put something in the box, it will remain in the box. That's why we are subtracting only 2. And that's the trick of the examiner. That's the trick of the examiner. Because many of us teachers, we have a tendency of now forgetting to emphasize the point where the height and how to get the new height. So in our case here now, the height is 15. You only take away 2 from the bottom, so the thickness of the bottom side, because it's not through 15. 15 now minus 2, you get now, our height now becomes 13. So here we have 26 times 21, then times 13. And if you are bright students, the volume of the big box is in the choice. The volume of the hole is also in the choice. So your work will be just subtract. But to avoid guesswork, it's good that we don't want to train lazy students. You have a lot of time. Do your work and get the right answer. In our case here, we have 30 times 25. 30, 25 class. This 25 times 3 is 75. So 30 times 25, in short, is 750. Then you multiply times 15. I think I'm clean there. 30 multiplied 25 is 750. Then multiply times 15. This is 5 times 0, you get 0. 5 times 5 class is 25. You have to write 5, carry 2. Then again, we have 5 times 7, 35. 35 plus 2 again, you get 37. Then 1 times 0, 0. 1 times 5, 5. 1 times 7, 7. Then now you add, you get the volume of the big box, which is 0, 5, 2, carry 1. You get 11,250 cubic centimeters. Take away now volume of the hole, so that you get the volume of the remaining timber. Now the volume of the hole now is 26 multiplied by 21 multiplied by 15. In our case now, we have 26 multiplied by 21. Class 1 times 6, very fast, 6. 1 times 2 is only 2. 2 times 6 is 12. 2 carry 1. 2 times 2, then you add 1, you get 5. In our case here now, we have 546. Then 546 again, you multiply by 15. Be very keen here again. These are the normal process which must be done by a serious candidate, not just guesswork. 6 times 5 is 30, 0 carry 3. This is 20 plus 3, 3 carry 2, 5 times 5, 25 plus 2, 27. I'm going very fast because already you know multiplication. 1 times 6, 6, 1 times 4, 4, 1 times 5, 5. Then when you add, you get 0, 9, 1, and 8. The volume of the hole is now 8,190. So what you do now, you subtract volume of the big box minus volume of the hole. Volume of the big box now is 11,250. Then you take away now 8,190. KCP question. 0 take away 0 is 0. 15 take away 9, you get 6. 1 take away 1 is 0. Then 11 take away 8 is 3. So volume in our case now here is now 3,060 cubic centimeters. That's how we get the volume of that box. That question was stated back in 1994. Some of you, they were not yet born by that time. And the same question will continue being tested. In the year 1992 again, they brought another figure, which also is not in the normal primary mathematics book. It's just a matter of combining shapes. But you are using the principle. You know, primary math, it gives you the basic things that you must know and you must understand. Now, here they brought a shape, the shape of a triangular prism, which is different from the normal triangular prism. That's the year 1992, question number 27. Question number 27. This is how the question was. That's a figure of triangular prism. Then again, look. No, I'm okay. Nimechukua muda. Okay. Volume of this question was stated back in the year 1992, question number 27. This is a solid. What the volume of the solid? And remember what I've said from the beginning. Master this. Volume is simply cross-sectional area. Area of the cross-section, the base area. In any figure, the base area is already drawn and is there. It can be seen. So in our case here now, when you look at that figure now, our cross-sectional area is just area of a trapezium. This is area of a trapezium. This one is a trapezium. So the examiner is only interested with now the area of the trapezium times the length. That was saying, don't be binded by the formulas. Open your eyes and see. This one, the trapezium. So we only need to get the area of the trapezium times the length. And area of our trapezium, we have done this several times in the class. It's just area of the trapezium times the length. Area of a trapezium is a half A plus B. Just a reminder, this line is called A, B, and the height. So a half into brackets A plus B, then times the height. In our case here, our height is 2. So it's simply very fast, it's a half. Then A plus B is the 2 plus 4, which gives you 6, then times 2. Very simple question, but very highly missed in exams by students who are not serious with what they are doing. By 2, 1, by 2, 1. 6 multiplied by 1 is 6 now cubic centimeters. That's how we get the volume of that figure. Base area times the length. Very good question. They have also given in the year 2013 cylinders inside another cylinder. What does it mean? You are given a cylinder, and just like the other diagram that I've only given, you are told there is a hole inside the cylinder. So what the volume of the remaining part? That was back in the year 2013. Back in the year 2013. You are given a cylinder, but there is a hole inside the cylinder. So this one is a cylinder, a very big one. Let me draw a very big cylinder for you to see. This is a big cylinder now. Then we have a hole. We have a hole. We have a hole now, like that. Then you are told the diameter of the big cylinder, you are given as 56. You are given the big cylinder as 56. The diameter of the big cylinder now, you are given as 56 centimeters. So now, and the hole now, you are given the radius as 7 centimeters. The examiner, I like these people calling the examiner. Now a student who doesn't understand the difference between diameter and radius cannot get that question. So now we get the volume of the cylinder, big cylinder, then you take away volume of the other hole, which is a cylinder. So volume of a cylinder, whatever we have done in class, should be phi r squared h. In our case now, volume of the big one now, if the diameter is 56, radius is 56 divided by 2. That's why we say it's only 22 over 7 multiplied by 28. 6 divided by 2 is 28, then times 28, then times the length. In our case here now, our length was 10 centimeters. So now times 10, now you get the volume of the big cylinder. By 71, by 74, we have 22 times 4, we have 88. 88, you multiply by 28. 64 carry 6. 64 plus 6, another 70. 6 carry 1, 17. This one is 24, 64. That's the volume of the big cylinder. Now you take away volume of the hole. Where the radius is 7, again you say 22 over 7, multiplied by the radius, multiplied again by the radius, multiplied the length remains the same, which is 10, by 71 by 71. 22 multiplied by 7, you get 154. Multiplied by 10, you get 1,540. So your work now, you just subtract, then you get the answer direct, which is now 2,464. Take away now 1,540. 1,540. Then the remainder is volume of the timber. That's the remaining. That's 4. That's 2. That's 9. So our answer was 924 cubic centimeters. That's how you get the volume of that figure. Volume, you are given the combined shapes, then you get the answer direct. Another question which is commonly in the exam, very common one, is now just cylinder. You are given a normal cylinder. These are very common questions in the exam. You are given a normal cylinder, you are given the diameter, you are given the height, you just work it out. And I only want to give you only one example, then I'm done, because this one we have constantly repeated in the class, morning hours, evening hours, we concentrate too much on the volume of cylinders. So like now the year 2006, they give you just a plain cylinder. And the students be very keen. I'm very bitter when I hear some of you missing simple question. If an examiner giving you just straightforward question, the diameter is 14 centimeters and the height is 10 centimeters. Then the examiner is asked a very simple question. What the volume of the cylinder? And you are given everything and you miss. This time around, I'm very strict with some of you. We are doing careless mistake. Want you to pass the exams. You are paying a lot of money. Pass the exams and the big doctor. You are doctors for tomorrow. Now, 5r squared. If the diameter is 14, what the radius? 7. So the same thing I've said. Get the area of the cross section. Just area of the circle, which is 5r squared. Then you multiply times 10. In our case here now, the diameter is 14, so the radius becomes 7. Now, so we have 22 over 7, multiplied by 7, multiplied by 7 again, then times 10. Very simple question. Then 7 will go with 7. 22 times 7 is 154. You multiply by 10, you get 1,540 cubic centimeters. Very straightforward question. But if the examiners can hear me, I don't wish that they bring straightforward question. We wish to see twisted questions so that only the bright students will pass that exams. For you to be very serious when you are doing exams. So that's all about volume. You have a very many books, revision book. Go and revise that topic thoroughly. Revise that topic thoroughly and bring the problems that you may encounter in the course of your revision. Thank you very much. See you in the next lesson.